The overrunning alternator pulley or alternator freewheel clutch. The overrunning alternator pulley is found in many modern cars. It prevents the transfer of the force from the alternator's moving rotor to the belt, thus reducing the dynamic load on the drive. You can now observe how the rotor continues to rotate after the belt drive has stopped. Thus, as the crankshaft rotates irregularly due to the staged combustion cycle and abrupt stops, when the alternator's rotor spins faster than the drive belt, the overrunning pulley rotates freely without transmitting force, reducing wear, vibrations, belt slips, and the overall load on the drive, particularly on the automatic belt tensioner. Additional benefits include reduced noise from the drive and slightly lower fuel consumption. Compare it to a regular pulley. In that case, the belt vibrates more vigorously and the tensioner's travel range increases. Furthermore, as the tensioner wears, the belt vibrations get more intense and the belt tensioner's travel range expands even further. You will find more 3D video lessons in our Car Anatomy online course. Let's review the design and operation of a typical overrunning alternator pulley. The overrunning pulley consists of the following major components: a pulley with an outer ring, a sleeve with an inner ring. The sleeve, with threads, is fixed on the generator rotor. Two radial bearings between the rings. In the middle, where the inner ring has special grooves, locking rollers are installed. The locking rollers are pressed in one direction by a spring, in this case a leaf spring, which is fixed on the cage. The cage is held in place by grooves on the inner ring. The other set of grooves is utilized to guide the locking rollers. The locking rollers allow the pulley to deliver torque in one direction while still rotating freely in the opposite direction without transferring forces. As a result, the spinning rotor does not transfer torque back to the drive belt. Let's have a look at how the pulley locks and spins freely in cross-section. When the belt spins the outer ring, the locking rollers, loaded by the spring and friction, move to the less deep part of the recess and lock the two rings together. The force is then transferred to the inner ring. If the pulley rotates in the opposite direction, the rollers move back and slip, preventing locking. The torque is therefore not transmitted to the inner ring. The roller travel is increased in this video for visual clarity. Similarly, if the rotor spins faster than the drive belt, the rollers travel back and slip, preventing locking. The torque does not get transferred back to the outer ring and therefore the belt. We have explored the operation of a typical overrunning alternator pulley. Finally, it is worth noting that the pulley is usually covered with a plastic cap to protect it from dust and filth.